Hey, what's going on, all y'all? Today I'm going to talk to you about similar figures. Similar. Now, similar has a special meaning in mathematics. A similar figure is going to have the same shape, or two similar figures are going to have the same shape, but they'll have different sizes. Okay, now, what that means is two similar figures are a dilation of one another. Okay, here's an example right here. These two figures are similar, which means that they have the same shape but a different size. Okay, and what is going to happen is that these two figures will be related by a scale factor, which I'm going to call k. Alright, now if I go in this direction, it's going to be called an enlargement, okay, because I go from small to large. Alright, so that means that k, the scale factor, is going to be greater than 1. Alright, now if I go from big to small, that's a different kind of dilation that's called a reduction, and I'll call this K2. Now, what it means when you do a reduction is the scale factor is going to be it's going to be between 0 and 1. So let me just fix this right here. Is greater than 0. The scale factor is going to be greater than 0. And it's going to be less than 1. So it's going to be between 0 and 1. Okay? Alright. So scale factor k is going to be greater than 0 but less than 1. It can be 1/2, 0.5, 1/4. It's just, you know, the smaller one is half the size or a quarter the size or something like that. Okay. Alright. So those are the two directions. If I go this direction, I'm making it bigger, so it's an enlargement. If I go this direction, that's a reduction, and I'm making it smaller. Okay, now since these two figures are similar, they're going to have the same shape. Now, what that means is that the corresponding angles are going to be congruent. Alright, so those two angles correspond to each other, so they're congruent. And these two angles are also be congruent. Now, congruent means that they have the same measure. Okay? These two angles correspond to each other. So they're going to have the same measure as well, okay? So this will have the same degree measure as that, that will have the same degree measure as that, and those two will have the same degree measure. Alright, now the sides are going to be proportional. Alright, and that proportion we can show related by the scale factor k. So let's imagine some numbers right here. Let's say that that's 1, 4, and 6. Okay. And let's say that this one is going to be twice as large. Alright? So let's say that the scale factor right down here, it'll be twice as large. Okay. Now what that means is that when I go in this direction, I'm going to multiply. Alright, so 4 times the scale factor 2 is going to give me a measure of 8. It's like 1 times 2 is going to give me a measure of 2. 6 times 2 will give me 12 over here. Now you can see that each one of the sides is twice as large as the other side, is its corresponding side. Okay? So 4 is twice, 8 is twice 4. Okay. Now if we go in this direction, since the bigger one is twice as large, the scale factor here is going to be 1/2. Okay, because this one's half as large as that one. Each one of the sides is half as long. And you can see, because if I multiply going in this direction, 12 times 1/2 is 6, and 2 times 1/2 is 1, 8 times 1/2 is 4. Okay? Alright. Now, let's say that we didn't know some of the things. So let's say that all we were given on this triangle is let's see. Let's say that we weren't given that, and let's say that we weren't given the scale factors. And let's say that I also didn't have the 12. Can I do it like that? Yeah, okay. So if we needed to solve, let's say, for x right here, and this is all that we were given, is 1, 4, 6, 2, and x. Alright. But we were told that these triangles are similar. That right there is the symbol that means similar. Alright, well, what we would do to solve that would be to set up a proportion. Alright, because we know that these two triangles are going to be related by a scale factor. So what I'm going to do right here is I'm going to say that this side is to that side, okay? And I'm going to say that they're in the proportion 1 to 2 is equal to, and now I'm going to pick another pair that corresponds. 4, which I'll put correspond, oh, I'm sorry, yeah, 4, which I'll put right here with the smaller one, and x right here, which I'll put with the bigger one. Wait a second. Okay, this is a pretty common mistake. 1 is to 2 because I put them one over the other. 1 over 2 is 4 over x. That'll give me x equal there. Yeah, that'll give me the wrong scale factor. Okay, that's not going to work for here. What I'm going to do is I'm going to say 1 right there, and I'll put the corresponding side over there. Okay, so 1 is to 2 as 4 is to x. Alright, now you see the difference right here. This is telling me that the proportion of this side to that side, if I put those two sides together, their measures, they're related in a 1 to 4 ratio. Is the same thing as these two sides together. Alright? Whereas if I look in this one, I'm looking at the ratio up and down. Alright? So the difference right here is, in this one, you're going to multiply by k in this direction. Okay? Since I'm going in this direction down here, it's going to be going left to right, or small to big. If I go here, I have to look at the scale factor is going top to bottom. Okay, it's really important how you set up your proportions, especially if you're trying to do cross multiply and divide. Yeah, let's not do that just yet. That's for a little bit later. Right now you have to understand the proportional relationship. Okay, so here's how the proportion works out. We're going small to large. So 1 times k is equal to 2, and 4 times k is equal to x. Alright, well, real quickly, I see 1 times k equals 2. 1k is equal to 2. I don't need to write the k, I just see that k is equal to, I don't need to write the 1, I just see that k is equal to 2. So down here I use the same k. 4 times 2 is equal to 8, so that means that x equals 8. Now, if I wanted to solve this, I would do it the same way, but top to bottom. 1 times 2, 4 times 2 is 8. Alright. That is how similar triangles work and proportions. Before we go, let's just do one more. Let's try and figure it out going large to small. Let's go across the top. Let's go in this direction. Okay. All right. Let's say that we were given the same information, but I wanted to find x2 right here, that side. All right. So let's start setting a proportion. Let's say that x2 and its corresponding side 6. It's going to be in the same ratio as 2 and 1. Other pair of corresponding sides. And this time we're going in this direction. Okay, so down here I need to find K2. Alright, so 1 times something is 2, is that right? Okay. Here's where it goes wrong. Alright, take a look. When we do these proportions, we're thinking about going left to right, okay? Because I put the big one on the left, and I put the small one on the right. So the direction is not going that way. We're going to go this way. Alright. Now we have big going to small when we go left to right. And this is a reduction. Now this one over here went small to big. So we knew it's an enlargement, and our scale factor was going to be greater than 1. Over here we're going big to small, and that means that our scale factor is going to be between 0 and 1. Alright, so take a look. 2 times scale factor of K2 is equal to 1. Okay, and to solve this we divide by 2. The 2's cancel out. Tells us that K2 is equal to 1/2. Alright? Make sure to pay attention to the direction that you're going, the big one to the small one or the small one to the big one, and you should be fine. Alright,